Okay, so this is lesson 43, Algebra 1. Again, this is lesson 43, Algebra 1. We're going to be talking about least common multiples. Okay, so to try and explain to you what that means, a multiple is kind of like when you skip count. So for example, you learn how to skip count by tens to 100 in kindergarten, 10, 20, 30, 40, 50, 60. And it's a multiple, meaning like 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, and so on. So that's what we do when we're doing skip counting. Okay, we're basically finding the multiples of that number. So we want to find a multiple that is the same for 5, 7, and 10, and we want the smallest one. Okay, so if you were to do this, maybe you'd say, okay, well, let's find the multiples. 5, 10, 15, 20, 25, 30, 35, 40, 45. Keep going here. All right, so we'll stop. We ran out of room there. Okay, so let's do this one. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 10, 20, 30, 40, 50, 60, 70. Okay, if you noticed, I stopped on the same number in each one. Kind of cheated, but so you do the multiples of 5, you do the multiples of 7, you do the multiples of 10, and you say, okay, well, which numbers are the same? Okay, well, I've got a 10 here and here, but there's no 10 in 7. I've got a 20 here and here, but there's none in 7 here. Okay, so I'm going to look for something that has a 5. Okay, we've got 35 and 35, but no 35 down here. Okay, so if I look hard enough and I'm trying to find my match, I just discovered that 70 is in all of them, and it's the smallest one that is the same. Okay, so if you kept going and let's say that you got to 140 and you said, oh, look, 140 is in 5s, 7s, and 10s. Well, that's all great, but you can actually use 70, and it's the smallest one that's the same, smallest multiple that's the same in all three. Okay, so 70 would be your least common multiple. 140 might be a common multiple, but it's not the smallest one. It's not the least. Okay, so let's say that we have something like this. We have to find the least common multiple of 8, 15, and 100. This is example 43.1 on page 172 in your book, if you want to follow along. Okay, so I could write out all of the multiples of 8, all the multiples of 15, all the multiples of 100, but it may not be getting me a simple, easy answer. It might be that there's an easier way to do it. So I will explain to you how they do it in the book. What we do is we're making and finding the prime factors of each one. Now we did this a couple lessons back where we said, okay, well, 8 is like 2 times 4. This is prime, so it stays. This is not, so we can break it down into 2 and 2. Okay, so suddenly this is 2 cubed, okay? 2 times 2 times 2. All right? So the prime factorization of this is 2 cubed, okay? So then we come over here and we say, all right, this is 3 and 5. They are both prime. So the prime factorization of 15 is 3 and 5. Okay, now we've got 100 over here. Let's say 10 and 10, and then 2 and 5, 2 and 5. Okay, so this is prime, this is prime, this is prime, this is prime. This is basically 2 squared times 5 squared. Okay, that's 2 squared times 5 squared, okay? 2 2s, 2 5s. 2 times 5 times 2 times 5 is 100, okay? So here we have 2 cubed, 3 times 5, 2 squared, and 5 squared. That's the prime factorization of all of these numbers. Now, how do I find the least common multiple using this information? All right, so what we need to do is we need to find what prime numbers we have, okay? So we have a 2, and we have to use the exponent that is the largest. Okay, so like we have a 2 cubed here, none here, and then we have a 2 squared here. Well, we have to use the biggest one, so we have to use 2 cubed. Okay, so now we've got our 2 down. Okay, so what's the next prime number that we've got? We've got a 3. There's no 3 here, there's no 3 here, and so there's just 1 there. Okay, so that's got to join the ranks here. And then we've got a 5 here and a 5 squared here. So we have to use the one that's the biggest amount of exponents. So we have to take the 5 squared. Okay, now then you can use your calculator, you can use your book, you can use whatever, but like pencil and paper, notebook, but you need to figure out what 2 cubed times 3 times 5 squared is, because that is going to tell you your least common multiple of those numbers. So if you were going to do the multiples of 8 and the multiples of 15 and the multiples of 100 and you make a big long list, you're not going to find a common one until you get to 600. Okay, so that is how you find the least common multiple of numbers, that when you don't want to write down every single multiple. Okay, so let's do another example. This is 43.2 in your book. We are supposed to find the least common multiple of 30, 75, and 80. So we're going to do the prime factorization again. Let's see. When you do this, remember, you just need to find 2 factors of 30. It could be 2 and 15. It could be 3 and 10. It could be 5 and 6. It doesn't matter. Okay, so I'm just going to go with 5 times 6. 5 times 6 is 30. Okay, this is a prime number, so I'm going to keep the 5. 6, you can take it and get it down to 2 and 3. Okay, so this is 2 times 3 times 5. All right, now we've got 75 over here. Let's do 5 and 15, I believe. Okay, and this is prime, but this is not. So this is going to break down into 3 and 5. So 5 times 3 times 5 is 75. So we're going to write down 3 times 5 squared. Okay, now we've got 80 over here. Let's do 8, 10. This is 5 and 2. Those are both prime. This is 2 and 4. Break that down. That's 2 and 2. Okay, so this is a lot of 2's. 1, 2, 3, 4 2's. 2 to the 4th. And then we've got 5. All right, so we've got 2 times 3 times 5, 3 times 5 squared, and then 2 to the 4th times 5. Okay, so we've got our prime factorization, and they said, okay, well, you got to find all your prime numbers that you've got. We've got 2 to start, and you have to find the one that has the biggest exponent. So that would be 2 to the 4th over here. And then we've got a 3. And then we've only got one of them here and one of them here. Okay, then we've got 5. 5 is the last one. We've got 1 here, 2 here, and 1 here. So we have to figure out the biggest exponent. So that would be 2 here. And when we times all of this together, we're going to get a least common multiple of 1200. Doesn't seem like a very small number, but that's the least common multiple of these 3 numbers. So hopefully if you can factor everything out, the prime factorization is probably the hardest part, because once you get there, all you have to do is find the exponent that's the biggest. Okay? So the prime factor and then the exponent that's the biggest between the 3 numbers. Okay, so you can also do this, find the least common multiple in these algebraic expressions. This is example 43.4 from your book on page 173. Okay, so we've got 15a squared b and we've got 10ab cubed. Okay, we need to do the prime factorization, so this would be 3 and 5, right? And then we've got a times b. They said to kind of break it out. I'm going to show you a little trick so you don't have to do that, but let's just break it out because that's how they say you want to do it in the book. So 3 times 5, and then you're supposed to write these out. So this is basically saying a squared is actually a times a, and then this is a b left, okay? This, if we broke this down, this would be 5 and 2, right? So 5 times 2 times a, and then 3 b's, because b cubed is b times b times b. Okay, so we have to use our prime numbers. So we've got a 2, we've got a 3, and we've got a 5. And fortunately for us, they're all ones, okay? The exponent is a 1. So we're not going to have a 2 squared, a 3 to the third, or anything like that, okay? Now we've got an A and an A here and an A here. Now remember what I said, you're trying to find the exponent that's the biggest. So we've got 2 A's in this one, so we're going to have 2 A's in here. I guess I can write it like this, okay? And then we've got 1 B here and 3 here, so we're going to need all 3 B's because that's the biggest exponent. Okay, instead of writing all of that out, I could have just looked at this and said, okay, I've got an A here and I've got an A here. This one's squared, this one's 1. So this is the bigger exponent. So I would just bring that down and say, oh, this is actually A squared. Okay, and then I would have looked at this. So this one has 1B, this one has 3. Oh, I better use B cubed. And then that I needed to figure out with my prime factorization. So 2 times 3 is 6, 6 times 5 is 30. So final answer looks about like that, 30a squared b cubed. That is the least common multiple of those two terms up there at the top. Okay, one last example. This is example 43.5 in your book on page 174. We've got 4x squared m and 6x cubed m. Okay, and we need to find the least common multiple. So I'm going to prime factor our 4 and our 6 and say, well, this is 2 and 2. This is 2 and 3. So really this is 2 times 2x squared m. And this is 2 times 3x cubed m. Now notice I did not write x times m or x times x times x times m because I just feel like that's an extra step that's not necessary if you understand the concept behind it, okay? So again, we've got, to find our prime numbers, we've got a 2 as a prime number, we've got a 3 as a prime number. Here there's 2 2's, there's 1, so this becomes 2 squared. There's no 3's here, but there's 1 here, so that we have to have a 3 down here. Okay, now we've got 2 x's and we've got 3 x's. Well, we want the bigger one, so we're going to go with x cubed over here. We've got 1m here and 1m here, so they're no different from each other, so we're just going to put m, okay? So 2 times 2 is 4, 4 times 3 is 12. 12x cubed m should be our answer.